This is Module 1, Lesson 4 on qualitative data. Hopefully you'll recall from an earlier lesson that qualitative data involves labels or descriptions of traits using words or phrases. And whenever we're trying to answer some sort of question, it is possible that you may collect qualitative data. When you go to answer that question, you have to organize your data in some meaningful way. One of the tools that we do that with in statistics is called a frequency distribution. Not only do you have to organize it, but you have to display it in an understandable way to your audience. Most often, researchers and people in general will use graphs to do that. And this lesson is going to go through and explain how to actually organize and display qualitative data using those two tools. So we're going to focus first on how do you actually organize the qualitative data. Specifically with qualitative data, we use what is called a categorical frequency distribution. And that is simply the organization of the qualitative raw data into a table form. Frequency distribution is a fancy statistical term for a table. Each table will list the categories alphabetically. Those categories or groups are called classes. In addition to the categories, we have a column to represent the tally marks or the tick marks, which indicate that that particular group has occurred within the data set. Then you have the frequency column, which indicates the number of times that that particular group or class occurred within the data set, which is written as a whole number. And finally, you have the relative frequency, which is the proportion of the class that occurs within the entire data set, which is written as a percentage. The relative frequency is used when we want to compare data sets of different sizes. The formula for calculating relative frequency is the frequency divided by the sample size multiplied by 100%. We also use our frequency distributions as a jump start for the graphs that we'll look at later on. So I want us to take a look at an example and walk through how to create a categorical frequency distribution. So we begin with a question. What is the most popular county of residence of Georgia Highlands College students enrolled in spring 2016? As we talked about before, it's important to know from the beginning what is your variable, your population, your sample, and so forth. So let's take a look at those things first. In this case, the variable is the county of residence, which is going to be a response like Bartow, Gordon, Floyd, Cherokee, which is definitely qualitative data, which is neither discrete nor continuous, and it's at the nominal level because one county is not necessarily better than another. The population or the big picture focus here would be all Georgia Highlands College students enrolled in spring 2016. The sample that I used is all students enrolled in 4 different sections of Math 2200 at Georgia Highlands College in spring 2016 on the Cartersville campus. If we think about the sampling technique that I used, this would actually be the cluster method because I used all the students within 4 different groups. It is random. There is some question about whether it would be representative since we only used students from the Cartersville campus. It would probably be better if I had some students from all of the campuses, including online. This is the raw data. These are the responses that I recorded from students about the county in which they live. And you'll notice there's really no rhyme or reason to it, and it would be very difficult to look at this list and answer the question. So that's why we want to try to organize it into a table form, which can help us come to an answer or get the final answer for our question. So to set up our categorical frequency distribution, we kind of draw us a table. We'll have 4 columns. The first column will be the county of residence and represent the different responses that were received. We list those in alphabetical order. The second column is the tally. Third is frequency, and fourth is relative frequency. So we go back through our raw data on the previous slide, and each time that that particular county occurs, I'm going to put a tick mark or a tally mark under the tally column. Once I've completed going through the list, I notice that there are 50 responses, and so I want to confirm that I have 50 tick marks, because if I miss one, then it throws everything off and I come up with inaccurate results. Once I've completed the tally, then I go back and count the tally marks and record the frequency. For example, if I look at Bartow, I have 5, 10, 15, 20, and then one more. So there are 21 students who indicated that they live in Bartow County. Again, when I finish doing that, I want to confirm that I have a total of 50 to make sure that I didn't make an error somewhere. Then to find the relative frequency, we take the frequency of the category. So for example, for Bartow, I would take 21, divide it by the total, which is 50. So 21 divided by 50 and multiply it by 100%, and my result is 42%. And then I proceed down through the other classes. Again, I have a self-check there because the relative frequency should add to or be close to 100%. We do sometimes round, and that can cause it to be a little bit more or a little bit less. And so this is a completed categorical frequency distribution. And even with this simple tool, we have enough information that we could answer the research question. But sometimes graphs are better than a table, because graphs are a lot more useful for communicating information quickly to a reader or someone who is perhaps listening to a presentation. Newspapers and the internet, television use graphs to show trends and to allow the readers to compare facts and figures more quickly. And although there are no strict rules about which graph to use when, a lot of times what you're trying to communicate, the information you want to share, is actually going to determine which is the best graph for you to use. There are primarily 2 different types of graphs that we use with qualitative data. The first of those is a bar graph, and the second is a pie chart. Now, you're not going to be asked to create these graphs, but you will be asked to interpret the information provided by those graphs. So let's talk about the different kind of graphs for a minute. This is an example of a bar graph for the data that we just organized into the categorical frequency distribution. On a bar graph, the height or the length of the bar represents the frequency for each category. Notice that there are gaps between the bars, since each category is what you could think of as being a standalone category. The student only lives in one county as opposed to 2 different counties. So it's a standalone category. Thus, you have the gaps between the bars. Graphs, regardless of whether they're bar graphs or circle graphs or pie charts, should always have a title with as much detail as possible so someone knows what the graph is all about. You also want to have labels for your vertical axis and your horizontal axis. The second type of graph that we can use with categorical or qualitative data is a pie chart. And again, the example on the screen is for the data of the county of residence for GHC students in spring 2016. Each piece or each